Good day, viewers. You're welcome to my YouTube channel, Maths with David and Victor Adewale Adeleke. Here, our major focus is to mathematics from the onset even up to tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share this video. It is very important so that whenever we post helpful materials like this, we always get notified. Okay, now let's talk about chain rule. Now, many of us will be saying, why are we not still using first principle? Yes, first principle can also be used to solve this particular kind of question, but you already know that what tarnishes or what destroys the existence of a formula or a regime is when a new potent regime that surpasses that other one comes into existence. So this, if you want to use the first principle or the derivative, that is the definition of a derivative, to solve this question, is going to take you hell of time. We are still going to come out with the answer if your steps are not mistaken or you fail. It's certainly going to give you the same answer. But this is a method, the chain rule, which is also called the function of a function. This is where it comes into more advantage than the definition of a derivative, which is also known as the first principle. So this one helps you perfectly to solve questions that are function of another function. You can see this is a function of another function. So we have y equals to 3x plus 2 to the power of 2. Now, someone will tell me, okay, just expand and do the normal first principle. Perfectly, it will work. Let's try that. Let's see if it will work. So we have that y equals 3x plus 2, another 3x plus 2. So you put your y. Don't forget, don't mistakenly put your dy dx, because we are still in the world of algebra. We have not done anything that has to do with calculus. This is still normal. We're just expanding brackets. So we are still in algebra. So when you expand this, we are going to get 9x squared, then plus 3 times 2, we have 6x. Okay, another 3 times 2, so we just have 12x, then plus 4. Then from here, what do? We can do the derivative. We can take the derivative. Sorry. Now I thought I gave a principle already that if y is equals to x to the power of n, then dy dx must be equals to what? Must be equals to nxn minus 1. So that's the same thing we're going to do here. So we cannot put our dy dx. So you have your 2 multiplying that, we have 18x 2 minus 1, then plus you have your 1, you have x to the power of 0. Note that. So 1 multiplies this, you have 12x 1 minus 1, then plus 0 multiplied, I have 0x 0 minus 1. So this one is already gone. Then what do we have here? We have 18x left, then plus 1 minus 1 is 0. Any x to the power of 0 is 1. Anything to the power of 0 is 1. So we have just your 12 left here. So what is common here? I think that's our final answer. Let's factorize it. So what is common here? I think we have 18 here, we have 12 here. So we have 6 common. So when 6 comes out from 18, you have 3x plus you have your 2. So this would be the answer to the question. To this question. So this is the dy dx. But using the chain rule principle, which is very, very reserving and very, it minimizes time, helps you a lot. So let's see what we can do here. Let's see what we can do. Now, one thing about the chain rule is, the formula for chain rule is that dy dx must be equals to dp dx, then times your dy dp. Another way I look at this is that dp as a fraction. I just look at it as a fraction. dp cancel out. It doesn't work that way, like that way anyways. But that is an algorithm or a mnemonic that I always use to remember the formula so I don't mix them up. So dp, you can see dp when they cancel out, we have just the y dx, still the same as the original fraction. It's not referred to as fraction, but as you can use that also. I just borrowed it out for you guys in case for examination purposes and all that. Maybe there's not much time to prepare for the exam. Just use that. What is p? Now p is the substitution that we are using for this. Okay, let me explain how it works. Now we have that y equals 3x plus 2 to the power of 2. So yeah, just say let the value of p be equals to 3x plus 2. Now we will differentiate p with respect to x. So we have dp dx, because we are differentiating p with respect to x. If you are having arrow equals to 2 any, if you want to differentiate because this is an equation. If you want to turn it to a differential equation, it becomes the arrow the n, because you are differentiating arrow with respect to n. But if you are differentiating n with respect to arrow, it becomes the n the arrow. So that's how it works for equation. So you can keep that in hand because of where we are going, so that we understand calculus more than just the basics. So that's what we're going to do here now. So when you do that, you know this is 2, which we already know about. This is 2, which is a constant, it turns to 0, because this 4, you can see that the 4 turned to 0. So constant always turns to 0. So this 2 here is going to become 0. So we have just 1 here. We have just 1 there. Coming. Okay, we have just 1 here. So what happens? The 1 multiplies the 3. We have just 3x. We have just 3x. So the x minus 1, we have 0, which is just 3. So we have just 3 standing. So once you've had that, don't forget, we said that let p be equals to everything here. So which means that y will automatically be equals to, since everything is now p, you have your p, you have your p to the power of 2. So since we have that, like I said, we are differentiating y now. The equation, this is an equation, y equals to p squared. So the derivative is going to be dy dp. So when you differentiate that, we have 2p. Now you can see we have the p dx and we have dy dp. So taking them back into that equation, we have that dy dx will certainly be equals to, what is dp dx times dy dp? What is that? dp dx, which is 3, times dy dp, and that will become 2p. So that will give you 6p. And do not forget, p is a substitute. So dy dx, sorry. So p is a substitute. And what was the substitute? What will we substitute as p? We have 3x plus 2. So we have 6. Then you have your 3x plus 2. This is perfectly, it worked perfectly. So this is a particular question solved with 2 different approach. Understanding. So the reason why this one is not really efficacious, effective when you are solving mathematics calculus, because you can have to the power of 100, you can have to the power of 50, you can have to the power of 25. So how are you going to do those expansion? Because we're fortunate enough to have a question that has to the power of 2, so we could do the expansion. But what about if we are having to the power of 6, 7, 12, like that, 30? Just use the chain rule and you'll still get the answer. And one very beautiful thing about this chain rule is that it helps you to factorize the question. Even if it's to the power of 4 and you have 3 cube here, or x cube, sorry, it's going to give you a factor, a well solved factor of what the answer is going to look like. So this is what it's all about. If you're yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post helpful materials like this, you will always get notified. Stay tuned.